We usually picture our planet as a delicate terrarium, a fragile blue marble suspended in the dark, one that requires perfect balance and constant protection to keep the ecosystem from collapsing. But that image ignores the reality of Earth's deep history. Over billions of years, this planet has been slammed into by city-sized asteroids, frozen into solid blocks of ice, scorched by lethal solar radiation, and choked by planet-wide toxic ash. Based on the standard metrics for planetary survival, a track record of that much violence should have left us a lifeless rock, indistinguishable from the inert planets drifting next door to us. Yet here we are. Earth somehow endured the exact conditions that sterilized every other planetary body in our solar system, which leaves us with a massive anomaly. How do you survive a deep space firing squad? Earth consumes these cataclysms. It uses the wreckage of a world-ending event to forge its next systemic upgrade.
4.5 billion years ago, Earth was barely formed when another planet named Theia crossed our orbit. A direct hit of that magnitude should have shattered the young Earth into a cloud of drifting dust. Instead of ending the planetary experiment, the violent collision ejected millions of tons of debris into a ring around the Earth. Over time, that superheated rock coalesced to form the Moon. This diagram compares a wobbling, unstable planet on the left with our Earth on the right. The Moon acts as a gravitational anchor, locking our axis into a stable 23.5-degree tilt. Without that tether, our climate would swing wildly, preventing the rise of life. Fast forward 2 billion years, and life had taken root in the form of single-celled cyanobacteria. These microscopic organisms began pumping massive quantities of a highly reactive gas into the atmosphere: oxygen. At the time, oxygen was a lethal chemical weapon. The sudden influx of this toxic gas poisoned the atmosphere and drove almost all existing life on the planet to extinction. But as the oxygen accumulated, it drifted high into the stratosphere and reacted with sunlight to build the ozone layer. By accidentally engineering this atmospheric shield, the surviving life forms blocked lethal solar UV radiation from reaching the surface. The specific forces that threatened to physically destroy and chemically sterilize the Earth provided the essential armor required for its long-term safety. Eventually, the planet faced the opposite extreme. Twice in our deep history, global temperatures plummeted so far that Earth turned into a giant snowball. Massive ice sheets crept all the way to the equator, and all potential for biological development was completely buried. Deep beneath miles of solid ice, a planetary failsafe was running. Underwater volcanoes and shifting tectonic plates continued to churn, pumping huge volumes of carbon dioxide out of the Earth's mantle and into the sealed-off atmosphere. Because the water was frozen, there was no rain to scrub the carbon out of the sky. The gas accumulated, trapping geothermal and solar heat until the temperature forced a rapid melt. That sudden rush of warmth and trapped nutrients sparked a massive, chaotic explosion of complex new biological diversity in the oceans. This line chart tracks marine species diversity. Look at the sheer drop 250 million years ago. That cliff is the Permian Great Dying, erasing 96% of ocean life. This wipeout removed dominant predators, creating a global biological vacuum with zero competition. The remaining survivors, the small and the hardy, suddenly had free rein. They expanded into those empty niches, branching out to become complex reptiles, dinosaurs, and eventually mammals. These resets are made possible by a permanent machinery that prevents the planet from ever staying frozen or scorched forever. This is the triple defense system: a magnetic field shielding the atmosphere, tectonic plates recycling carbon for heat, and oceans acting as thermal buffers. Without these mass death events clearing the board and the geological engines that pull the planet back from the edge, the biological innovation required to produce complex life would have been impossible. Every defining feature of our existence is a direct byproduct of a near apocalypse. We have a stable climate because another planet hit us. We breathe oxygen because a toxic gas poisoned the ancient atmosphere. We are dominant mammals because a global wipeout cleared the way. Disasters are the actual mechanisms the planet uses to force evolution forward.
This history places our current environmental and climate challenges in a different context. Earth is a battle-hardened survivor. It has navigated miles of solid ice and skies choked with ash, and it will persist through the current crisis. The uncertainty lies with us, whether we possess the evolutionary adaptability to remain part of the planet's story. Let us know how you think we'll handle the next planetary reset down in the comments.